Right, now we looked at the FIFO page replacement algorithm. We saw this example, and a lot of the times, if you noticed carefully, you would remove a number and put something else, and in the very next iteration, the number you just removed is what you need. So you have to bring it back again. So for example, if you look at these last cases, there's a 7, 1, 2. I need 0. 0 is not here. I'm removing this 1 and I'm putting 7, 0, 2. Now the immediate next number I want is a 1. So again, it is not here. I have to remove this 2 again and bring in the 1. So that kind of situation happens almost 2-3 times within this example itself. For longer reference strings, it is easy to understand that this might happen. So naturally you would think if I had more frames, then there would be fewer page faults. So here my RAM size is only 3 frames, right? If I had 4 or 5 frames, maybe I would be able to accommodate more pages at the same time. I wouldn't have to do so much kicking out so frequently. That's a natural thought to have. But if you try this example with 3 frames, you will find out that you get 9 such page faults. If you look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So for this example, with 3 frames, we got 15 faults, right? So if you take this example, you try with 3 frames, you will get 9 faults, but with 4 frames, you will get 10 faults. So what's happening here is, it's the same logic as this one, so I'm not working this out explicitly. I would encourage you, however, to pause for a moment and actually try drawing the frame diagrams like this for this example, both for 3 frames and 4 frames. That will give you a good understanding. So what I'm trying to tell you here is, we might think when you have more RAM space, then you're going to have fewer page faults, but that is not necessarily the case. Sometimes even with more frames, you might end up having more faults with the FIFO algorithm. So this is called Belady's anomaly. This is the condition that exists, right? So the conclusion is, FIFO is not really the best possible page replacement algorithm. So obviously the next question is, can we do better, which we'll look at in the next segment.